Hello, dear friends. Welcome to Billion Hopes AI. This is Mentor Sandy bringing you AI for real impact. Today, we will talk about the epic battle brewing between US and China on AI domination at multiple levels. As we know, Jensen Huang of Nvidia, the visionary chap, has built a whole ecosystem around the CUDA framework. And now China is determined to break it via some Huawei innovations called CANN. This is exactly what we are going to see today. This is an infrastructural war happening, and this can lead to significant changes in the way AI operates in the market. Nvidia being the very clear hardware leader. I invite you to join our channel. Please click the join button and check out the various levels and choose the one that suits you the best. Thank you so much. China is actively trying to reduce dependence on Nvidia, especially due to US export controls on advanced GPUs. Under Donald Trump, continuing with Joe Biden's policy, as we know, exports of absolute cutting edge chips to China have been reduced drastically. And because of that, China was forced to innovate on its own. For Nvidia, CUDA is a major lock-in advantage. The whole ecosystem, CUDA plus libraries, is a strategic moat. So a strategic moat in AI is a competitive advantage that no one can truly break easily. It's built over the decades. CUDA is a mature global standard, and China's CANN is early stage and mostly domestic. But then given the kind of resources China can muster, it can any day become a global standard. So the contest is multi-layered. It's for chips, software ecosystems, talent, data, capital, and policy. So we are witnessing an absolutely epic battle now taking shape. So this might sound a bit technical, but be with me till the end so you will understand the whole dynamic of what we are trying to see here. So that mic seemed to arrive and vanish at will. Interesting, huh? So what exactly is NVIDIA's CUDA? The platform, as we know, when we talk about compute unified device architecture, that's the original acronym when this thing was conceived. It's now a very powerful parallel computing platform and API, actually the one that's making AI possible in the modern parlance. How do you really make all these GPUs work together productively? This is what CUDA actually does. It allows general purpose computing on NVIDIA GPUs. Originally, they were created for video games. So there are developer tools, there are libraries, and there's a programming model. The core concept, if you look at the CPU, the one you're using in your laptop or a computer right now, so the traditional CPU might have very many large cores optimized for sequential tasks, one after the other. But then, as we know, deep learning, AI, and LLMs and artificial neural networks are all based on parallel matrix multiplications. Otherwise, the neural networks are of no use. So CUDA-enabled GPU, thousands of small cores optimized for very elementary parallel matrix multiplication tasks. So they are optimized for that, which CPUs are not. So that's the CUDA effect, unlocking massive parallelism. I hope that's very clear. So that's thousands of tasks at a time. That is how the CUDA framework was evolved over the years. And how exactly does it work? The software stack for CUDA. There is the NVIDIA GPU hardware at the base of it. Then CUDA parallel computing platform and application programming interface on top of it. Then CUDA accelerated libraries, CUDNN, CUBLAST, TensorRT, and finally applications and framework that sit right on the top that you and me interact with. So this is how the whole ecosystem works. And this is the simple workflow. Copy data from CPU memory to GPU memory. CPU instructs GPU to execute parallel code. GPU's CUDA codes execute kernel on data in parallel and copy result from GPU memory to CPU memory. So this might be too technical, but broadly the idea is that this entire ecosystem of CUDA was built by NVIDIA as a strategic moat for itself, and it has done wonders for its market reach and market valuation overall. So, it is a parallel computing platform and a programming model to use GPUs for general purpose computing, going beyond what the original purpose might have been, video gaming and others. It only runs on Nvidia GPUs. And this is what gives Nvidia a massive edge in the market. The customers, enterprises, or anyone else locked into CUDA once is kind of locked forever, and there is no way out of it. So that tight coupling is a strategic moat. Lock-in. Developers will write kernels in C, C++, Python extensions, giving fine-grained control. There's a massive ecosystem behind it, nurtured by Nvidia. And the use case is extremely broad. General purpose GPU computing, AI simulations, rendering, scientific computing. It's not just pure AI work. So this is how CUDA controls the market. And if you want to visualize it, this is how the visualization might look. Don't worry too much about the technicalities behind it. Just understand that in this global strategic battle on AI, China realized it early on that its tight dependence on the CUDA structure will never allow it to break free. And hence, we will now see what the Chinese are trying to do. So the news arrived that DeepSeek V4 is a big promise loading. It wants to break this CUDA stranglehold. The economic shock in terms of sheer cost reduction, trillion parameter scale at fraction of compute. This is what DeepSeek V4 will promise, and kind of a democratization wave, hardware democratization. You do not need to rely on CUDA anymore. But then how will this happen? What is the alternative structure being proposed by the Chinese? So here it is. How does the DeepSeek V4 challenge the Nvidia paradigm? First is algorithmic efficiency, the mixture of experts evolution. Second is software-defined compute. The third is token price war. And finally, hardware decoupling. DeepSeek is the one in Feb 2025, the company that actually brought a model in reasoning tasks. It totally broke the cost structure. Now we come to the crux of the matter. We come to Huawei's CANN, CANN, Compute Architecture for Neural Network. This is the proposed alternative to NVIDIA's CUDA. So let's understand what is Compute Architecture for Neural Network, CANN. This is an AI acceleration platform. Huawei has invested heavily in it. Heterogeneous computing architecture, specialized toolkit for AI scenarios, provides unified access for device, edge, and cloud. AI framework, Ascend AI hardware, and CANN is the one linking them. Why CANN? So, as we have seen in a traditional CPU, we get the sequential processing, which is not very good for AI because you need to do millions of parallel matrix multiplications there. So, Huawei Ascend NPU, specialized AI cores, parallel processing, and massive parallelism unlocked by CANN. So, this is exactly what CUDA does, but Huawei gets its own hardware to do that. So, here, Huawei is not using anything from NVIDIA, but doing its own thing. And the software stack for CANN, Compute Architecture for Neural Networks by Huawei, is this. So this is how they are preparing to slowly replace or at least create an alternative for everyone for CUDA. From model to deployment. This is how it will go. The idea here is that they want it to be applied to AI model training, AI inference, scientific computing, autonomous driving, smart video analysis, and so on. China wants no American company to dominate it at any step of the infrastructure layer. And that is easier said than done because given the research depth in America, it has taken 40 to 50 years of constant investment to reach this level. So China is playing catch up. And in this case, China truly is catching up And maybe another 2 to 3 years, we will have capabilities at par. No other country is doing this, at least not at the moment. Maybe some European company in the future might. So Huawei's CANN is a complete AI computing stack to replace Nvidia's CUDA. They may not be saying that in as many terms right now, as many words right now, but this is eventually the goal. And that is why I took up this very important topic, because I can realize the kind of thought which is going behind it right now. Hardware dependency, it is specifically built for Ascend AI chips. As we understand, CUDA is built specifically for Nvidia GPUs. So this is a strategic moat. Once again, they'll create a lock-in. You cannot go back to CUDA. Focused on graph-based compilation rather than manual kernel coding. AI-first design, primary for deep learning workloads, training plus inference, not broad, high-performance computing tasks. So this is even more specifically geared for AI. Clearly, for the next 10 years, China wants to very broadly deploy AI throughout the society, throughout the government, throughout the culture. And for that, it doesn't want CUDA dependence, which seems to be a very good national strategy. As far as other countries like India or the Europeans or the South Americans or others using AI at a higher level, there is no escaping CUDA as such. This will be integrated with Huawei stack, especially MindSpore. So if you compare the two, CUDA versus CANN, the differences, this is from Nvidia, this will be from Huawei of China, a completely proprietary architecture optimized for the Ascend chips, and CUDA is developed by Nvidia for the GPUs made by Nvidia. They might be fabricated by TSMC Taiwan, that's a separate issue. Hardware support, they only use Nvidia GPUs, and here they are optimized for Huawei Ascend AI processors, NPU. In a different video, I have covered this idea of NPU. Since you are here, I request you to please subscribe to our channel. Please do leave a comment or two explaining your perspective on this issue and anything else you wish to add technically to this, and do like this video. Thank you so much. Ecosystem maturity. Naturally, Nvidia is fully mature and established. Very massive libraries, widespread adoption, very large global community. And this will be growing and focused. So naturally, China will be the launch pad for it. And given the scale of China, it's a matter of time before it starts rivaling the scale of Nvidia's CUDA ecosystem. Versatility and scope. This can be used for scientific simulation, video rendering, data analytics, ML inference, general parallel tasks. So this is for general purpose parallel computing. And this is highly optimized for AI. So maybe that will be another moat they'll create other than their self-dependence. It is optimized for general massive parallelism, and CANN from Huawei is optimized for tensor, metric operation, and dense deep learning graphs. So I hope you enjoyed this very quick, deep understanding of CUDA versus CANN. China is actively trying to reduce dependence on Nvidia. This is where we started, and this is where we are concluding it. CUDA gives a major lock-in advantage, which China is extremely uncomfortable with, and hence CANN. I hope you enjoyed the video, and I hope you'll definitely subscribe to our channel and like this and share some thoughts in the comment. Please click the join button and you will see 3 wonderful membership levels. Hope to see you in at least one of them. Thank you so much. So China determined to escape Nvidia's AI grip. Let's see how quickly China is actually able to make a difference and convert CANN and CANN into a global standard. This is Mentor Sandy bringing you AI for Real Impact. See you soon.